Hi everybody, in this video we are going to talk about angle measures, specifically the measure of degrees, which should be familiar to most of you. Now, it turns out that in our degree measure, one rotation is equal to 360 degrees. Okay, as a consequence, 1 degree is 1/360th of a complete rotation. Now this all came about thanks to the Babylonians, because they realized that that the Earth rotated the Sun in 360 days, 365 days, and they also knew that 360 had a lot of divisors, which made the math really easy for a variety of situations, and therefore they defined a degree as 1/360th of a rotation, or that one rotation would be 360 degrees. Okay, and we also divided the degrees into minutes and seconds, just like we divide time into minutes and seconds. Specifically, 60 minutes equals 1 degree, 60 seconds equals 1 minute, and 60 squared seconds, 3,600 seconds, equals 1 degree as well. And of course, we could also express angles in decimal degrees. So we actually have two ways of expressing an angle: in degrees, minutes, and seconds, or as a simple decimal. And the most trivial example might be, well, 12.5 degrees and 12 degrees and 30 minutes. Remember, 30 minutes, that's half of a degree, so that would be 12.5 degrees. One of the things that you are going to have to do, at least in this section, is to convert between degrees, minutes, and seconds, and degrees, and decimal degrees. And here is how we can go from DMS to actually decimal degrees. So suppose that you have an angle that has A degrees, B minutes, and C seconds. If that's the case, then in decimal degrees, theta is going to be equal to A plus B divided by 60 plus C divided by 60 squared, or 3,600. As an example, let's suppose that we have an angle that is 91 degrees, 35 minutes, and 46 seconds. Okay, then its decimal equivalent is going to be 91 plus 35 divided by 60 plus 46 divided by 60 squared, which will give you this. Now, going back the other way is a little more complicated, or it looks a lot more complicated on paper, but is not necessarily that bad when you look at it from a calculator's perspective. All right, so now suppose that you have an angle theta in degrees format, or in decimal degrees format, which means there's going to be this part, and then there's going to be the decimal part. Okay, well, clearly, in DMS, A is equal to A, so this is basically A degrees. And then we can find the number of minutes by basically by taking the fraction part, multiplying it by 60, and then just taking the whole number part, and then just taking the non-decimal part out of that. That's pretty much what the floor function does. For example, if I did 60 times D, I'm going to get B dot whatever I have in the decimal, which I call remainder, okay, which is what this value is here, okay, and how we would compute that. All right, so once I have found that remainder, I can multiply it, or that decimal part, I can multiply that by 60, and then that will give me C. And as an example, well, let's just go ahead and go back the other way. Here, I have 91.596 with a bunch of ones after that. All right, so if that's the case, then the number of degrees, 91 degrees. How many minutes? Take the fraction part, multiply it by 60, and that will give you 35. Okay, now it turns out that 60 times this is going to give you 35.7666, all of this. So now all that we have to do is take the decimal part, multiply that by 60 to get the number of seconds. Now notice that there is a discrepancy between the number of seconds here and the number of seconds here. Okay, and that basically has to deal with the rounding area, because the precision here is not absolute, and we actually and we lost some precision due to the rounding on the calculator, but not really all that much. Now, it would be instructive to see how this looks on the calculators, on our calculator. So let's go ahead and do that. It's also helpful to see how it's done, and so you know how to take advantage of your history on your calculator. Okay, so to go from degrees, minutes, seconds to decimal, that is just simply 91 plus 35 divided by 60 plus 46 divided by 60 squared, or 3,600, and there you go. Now to go the other way, notice, okay, well, A is 95, cool. Now or 91, cool. Now I want the fraction part. Well, I can just subtract 91 from that. Okay, there's my fraction. Multiply that by 60 times 60. Those are my minutes. Okay, now subtract the number of minutes. Now I just have my fraction part. Multiply that by 60, and those are my seconds. Now, in this case, I'm not using the truncated answer, so it came up a little bit different. But that's pretty much how it can come back. Now, the other thing that we're going to be dealing with is the addition and subtraction of angles. And if you have an angle expressed in degrees, minutes, and seconds, there's a number of ways to do this. But I think the easiest way for us is going to be to convert decimal degrees, add and subtract, and then convert it back. You can do it directly with minutes and seconds, but there are carrying and borrowing issues that you have to deal with, similar to the carrying and borrowing issues you have when you are adding and subtracting values. Okay, and if it is in just decimal degrees, not a problem, just add and subtract. So let's go ahead and do this for a couple of examples. Here we want to perform this calculation: 28 degrees, 35 minutes, plus 63 degrees and 52 minutes. So my approach, once again, and I'm going to show this using your calculator, is first convert these two into decimal degrees. Okay, so for the first one, that's going to be 28 plus 35 divided by 60. There you go. For the next one, it's going to be 63 plus 52 divided by 60. Okay, now we can add them up. And I would encourage you to use the history on your calculator. What you don't want to do is write down a truncated version of these numbers, because if you do, you're going to have precision problems and you will most likely will get the wrong answer. So highlight this value right here. That's the decimal value for 28 degrees, 35 minutes. Hit enter. Plus, highlight this value. Hit enter. Hit enter again. That is our answer in decimal degrees. Okay, so we know that our answer is going to have 92 degrees, and then we can determine the number of minutes by subtracting 92 and then multiplying that by 60. And we will have 27 minutes. So our answer here is 92 degrees and 27 minutes. Okay, well, what about the next one? Well, for this one, once again, we want to convert both of these into decimal degrees. Well, this is already converted into decimal degrees, so we don't need to worry about that. But this one we need to work with. So that is going to be 117 plus 29 divided by 60. Okay, and then our answer is going to be 180 degrees minus this value right here. And there we go. So we know that our answer is going to be 62 degrees. And to find the number of minutes, we can subtract 62, multiply by 60, and we get 31 times 31.000002 minutes. We don't need to worry about that. That's just going to be 31 minutes. Now, the next thing that we're going to need to do is, in this example, is convert to decimal degrees for the first one, and then to DMS for the second one. So the first one's relatively straightforward. That's just going to be 105 plus 20 divided by 60. 105 plus 20 divided by 60 plus 32 divided by 3,600. And that will give me 105.342 degrees, because we only want to go to the nearest thousandth. So 105.342 2. Okay, now my fourth decimal place is also 2, so that tells me I don't need to round up, so this will be 105.342. Okay, and then for the next one, we need to convert this to DMS. So we know that we're going to have 85 degrees. To find the minutes, I want to take the fraction part, 0.263, multiply that by 60. That gives me 15 degrees. Okay, and now I want to subtract 15 and multiply that by 60. That gives me 46.8 seconds. And once again, we want to round to the nearest second, so this is going to round up to 47 seconds. That will give me 85 degrees, 15 minutes, and 47 seconds. Okay, now, for our last problem, we want to deal with the angle between the minute hand and the hour hand when the time is 9:45. So we're looking for this particular angle. Now the first thing we need to do is figure out what the angle is between 9 and 10. Okay. Now notice here we have 12 divisions, right? For numbers 1 through 12 covering a for a full circle. So that basically means that that in 360 degrees we have 12 divisions, which basically means we're going to have 30 divisions per degree, or 30 degrees per division. Okay. Now also notice that when it is 9:45, the hour hand is basically 3/4 of the way to the 10 o'clock point. In other words, the angle here is not necessarily 30 degrees, but 3/4 of 30 degrees. Okay, which equals 22.5 degrees. Okay, so that is our angle in decimal format. What is that in degrees, minutes, and seconds? That will be 22 degrees and 30 minutes. And that would be our answer. Okay, and that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.